In the next three videos, starting from this one, I'll be talking about operations with surds. So this first one will be about adding and subtracting like surds. And then afterwards, we'll talk about multiplying surds. And then we'll talk about dividing surds before we continue with other aspects of the surd playlist. Okay, so adding and subtracting like surds. In a previous video, I had mentioned it, especially, I think that must have been uh, video 4 where we talked about types of surds. Then we saw pure swords, mixed swords, uh, like swords and unlike swords, where we said that like swords actually have the same radical part, and I think I must have mentioned that you can only add and subtract like swords. So, and that's why this video is on like adding and subtracting like swords. So by the end of this lesson, you should be able to understand what swords are. Of course, maybe you already do that, but if this is your first video you're just seeing in this series, this is also helpful for you. Then you identify like sorts, add and subtract sorts with the same radical, simplify expressions involving sorts, and explain why some sorts cannot be combined. So we go straight to remind ourselves of what a surd is. So again, a surd is an irrational number written using a root symbol that cannot be simplified into a rational number. So not all, like we said in the previous video, right? Uh, Not all irrational numbers are surds, but all surds are irrational numbers because we have irrational numbers like pi, but it is not a surd because it doesn't have a root symbol. All right. So examples of surds are root 2, root 3, root 5. These are all, they cannot be expressed as rational numbers. That is, they cannot be expressed as the ratio of two integers. So these numbers cannot be written exactly as fractions. That's what I'm saying. For example, the square root of 2 is 1.41421356. So it's in decimal form that is non-recurring and it is non-terminating. As a result of that, it means that it cannot be expressed as a ratio of two integers. It cannot be expressed as a fraction like that. So the decimal continues forever without repeating. So we keep it in surd form as root 2 like that. So we then move on to structure of a surd. So a typical surd expression has the form a root n, right? Where a is the coefficient, that is number outside the root, and n is the radicand, that is number inside the root. So we have a coefficient and a radicand. And of course, we have the radical, which is the square root sign. So an example is 5 root 3. So the coefficient is 5, the radicand is 3, the radical is the square root sign like that. And we also have seen that the radical can be square roots, cube roots, fifth root, fourth root, and all of that. So now we talk about like sorts. Since we're talking about adding and subtracting like sorts, right? So sorts are like sorts if they have the same radical part. So this means the number inside the square root must be identical. So the general form, you have a root n and b root n. Since the radicand n is the same, then these sorts are like sorts. So if the radicands are the same, and of course the radical is the same, then you can say that you have like sorts. So this is square root of n, this is square root of n. If this was square root of n and this was cube root of n, you cannot still say they are the same, right? So if the roots, if it's the same radical and the same radicand, then you say you have like sorts. So the following are like sorts: 3 root 5, 7 root 5, and minus 2 root 5. They are all like sorts because they have the same radical part. Root 5, root 5, root 5 is common to all of them. So because of that, you can say they are like sorts, and then you can add these sorts and you can subtract them. So they all contain root 5, right? So only the coefficients are different. So as far as the radical parts are the same, then you can say they are like sorts. So then for unlike sorts, the following are not like sorts: 4 root 2 and 3 root 3, because the radical part here is root 2, the radical part here is root 3. So the radicands are different since root 2 is not equal to root 3. Therefore, they cannot be combined. So you can't add or multiply, you can't add or subtract these two sorts. Of course, you can multiply, you can divide, but not add or subtract because only like sorts can be added or subtracted. So combining coefficients now, when sorts are like, we add or subtract only the coefficients. So because the radical parts are the same, so we can add and subtract the coefficients. So the radical parts remain unchanged. So the general rule for addition is such that a root n plus b root n is equal to a plus b root n because the radical part is common to both. It's more like it's a kind of factorization in a sense. So same goes for subtraction. A root n minus b root n would just be more like factorizing root n, and you have a minus b root n. So like that. So example one now, you have, you want to simplify 2 root 7 plus 5 root 7. So both terms contain root 7. So they are like sorts. So, and since they're like sorts, you can add them together. So you just have 2 root 7 plus 5 root 7. So you just add 2 and 5, or more like factorize root 7. So you have 2 plus 5 root 7. And the result is 7 root 7. As simple as that. Then example 2, you have 6 root 3 plus 4 root 3. They are definitely like sorts because they have a common radical root 3. So add the coefficient, that's 6 plus 4, then multiply by root 3. Or if you like, you can say factorize root 3. So you have 6 plus 4 into root 3, and that is 10 root 3. Easy peasy. Then subtraction goes the same way. For subtraction, imagine you have 9 root 2 minus 4 root 2. Identify the common radical, which is root 2. Then subtract the coefficient. So you have 9 minus 4 root 2. So that means you have 5 root 2. Example 4, still talking about subtraction. You can simplify 7 root 6 minus 10 root 6. The common radical is root 6. So subtract coefficient. So you have 7 minus 10 root 6. 7 minus 10 is minus 3. So 7 root 6 minus 10 root 6 is minus 3 root 6. So straight to the point. So let's talk about um, simplifying sorts first. So sometimes you don't have the sorts in their basic form as you're going to learn very soon, or as we've learned in the previous video. So sometimes you may need to simplify the sorts first before you add or subtract. So imagine this case now. So sometimes sorts must be simplified before combining them. So imagine you have root 8 plus root 2. Clearly, it doesn't look like you can add the two together. But of course, 8 is looking like a number you can break down further. So for instance, if you simplify it, root 8 is the same thing as root 4 times 2. And root 4 is 2, root 2 remains root 2. So 8 now is 2 root 2. So so you can then combine 2 root 2 plus root 2 because they are like sorts, because they have the same radical part, root 2. So 2 root 2 plus root 2 is now 2 plus 1, root 2. Okay, so it's more like 2 oranges plus 1 orange. That is 3 oranges. So that's 3 root 2 in this case. So it bears some resemblance with algebra. Now look at this now. Why root 2 plus root 3 cannot be simplified? If you consider the expression root 2 plus root 3, these are unlike sorts because the radicands are different. So root 2 is not equal to root 3. As a result of that, they cannot be combined. So the best way to leave them is as root 2 plus root 3 because you can't simplify further. So we have an algebra analogy for this. So just like I talked about oranges, more like adding oranges before, like 2 oranges plus 1 orange, we give you 3 oranges. So, but you cannot add oranges and apples, right? So 2 oranges plus 3 apples cannot be added. So you just leave it like that. So the algebra analogy is this situation is similar to algebraic terms. So imagine you have 2x plus 3y. Since x and y are different variables, the terms cannot combine. Similarly, you can say root 2 plus root 3 cannot be combined. So these radicals are different. So the expression cannot simplify further. So you just leave it as 2x plus 3y, just like you leave root 2 plus root 3, just the way it is, because you can't do it further. But then we can have a numerical illustration. So the square root of 2 is approximately 1.414 into 3 decimal places, and root 3 is approximately 1.732 to 3 decimal places. You can then add them, 1.414 plus 1.732, and you have 3.146. So there's no simple surd equal to this value. So there's no surd that is equal to 3.146. So the expression remains root 2 plus root 3. That's the best way you can have it, like that. Okay? So you can go numerical or leave it like that. Then, how do we combine like surds now? So combining like surds is the next thing I want to talk about. Okay, I guess I want to go step by step here. Yeah, so combining like multiple like sorts. So you want to simplify 3 root 5 plus 7 root 2 minus 2 root 5 plus 4 root 2. So you collect like terms. So you have to group like sorts. So you have 3 root 5 minus 2 root 5 because they have the same radical. Then 7 root 2 plus 4 root 2 because they have the same radical root 2. Then just like we know to subtract, just subtract the coefficients. So you have 3 minus 2 root 5 and then 7 plus 4. So for 7 plus 4, you have 11 root 2. So at the end of the day, 3 minus 2 is 1. 1 times root 5 is root 5. 7 plus 4 root 2, that's 11 root 2. So all these multiple radical sorts now, you can combine them together to get root 5 plus 11 root 2. And you can't simplify further because the radicals are different. Okay, so look at example 6 now. You have 2 root 18 plus 3 root 8. Clearly, 18 is not looking like it's in the most basic form it can be in because this 18 should actually be a number where that you cannot factor out a square root from. But 18 is clearly can be split into 9 times 2, just like 8 can be split into 4 times 2. So root 18 is root 9 times 2, and that's 3 root 2. Root 8 is 4 times 2. Root 4 times 2, that's 2 root 2. And then you can see the simplified form. So 2 root 18 now, 2 root 18 is the same thing as 2 multiplied by 3 root 2 here. And 3 root 8 can be simplified into 2 root 2. And then you can multiply out. So you multiply out, you have 6 root 2 plus 6 root 2. And that means you have 6 plus 6 root 2, which is 12 root 2 in that case. So in essence, we have some key rules to summarize adding and subtracting like sorts. Only like sorts can be combined, always already established. So a root n plus b root n is equal to a plus b root n. So sorts with different radicals cannot combine, like root 2 plus root 3 cannot combine. Always simplify sort first when possible. So if you have a case where the sort is not in simplified form, you have to simplify first. Like root 8 is the same thing as 2 root 2 before you can then add that to root 2 to give you 3 root 2. Then sorts behave like algebraic variables when combining terms. Okay, so we have some practice problems right here. As usual, I'll take one from each part. Um, looking for which one to go for. Okay, let me take this one. 8 root 7 minus 3 root 7 plus 5 root 7. 8 root 7 minus 3 root 7 plus 5 root 7. 8 root 7 minus 3 root 7 plus 5 root 7. So here, since they all have the same radical, so you can just do the maths with the coefficients. It's more like you're factorizing out root 7 in short. So you have 8, this 8, okay, you have this 8, so this is 8 minus 3 plus 5 root 7. And then that is equal to 8 minus 3 is 5. 5 plus 5 is 10. So that's simply 10 root 7. And that's what you get for that, straight to the point. Then we have the next one. The next 10 now you have, okay, you have all these ones. Yeah, as usual, I think I'll go for the last one. 2 root 72 plus 3 root 8. 2 root 72 plus 3 root 8. Okay. So 2 root 72 plus 3 root 8. Okay, we're already used to this idea that this is 2 root 72. 72 can be written as 36 times 2. You go for the biggest perfect square. You can factorize from that. Then root 8 is 4 times 2. So from that now, we know this is 2. Root 36 is 6. So the 6 will come out to multiply these two that was already there. Then you have your root 2. This is plus actually. This is plus. Then here you have 3. You have plus 3 times square root of 4 is 2. Then you have that root 2 right there. So you can then have 2 times 6 is 12. You have 12 root 2 plus 6 root 2. So then you can then add the coefficient. So you have 12 plus 6 all into root 2. So at the end of the day, you have 18 root 2. So all of that is 18 root 2. So if you don't have it in the smallest, in short form, you have to reduce to something smaller so you can then finally add. So with this, we come to the end of this interesting video about adding and subtracting surds. So be sure to try your hand on the questions. This you have 1 to 10 here, okay, and then you have of course this question 9. To combine this, you have 4 root 5 minus 2 root 5. That's 2 root 5 plus 6 root 2. And you can't go further than that because the radicals will be different in that case after you've done that first step. And then you have 11 to 20 here. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. If you haven't subscribed, what are you waiting for? Go ahead and subscribe and hit the notification bell so you can always get alerted each time a new video is released. All right. Also, you can become a member of this channel by clicking on join. That gives you special privileges like you getting to see some videos first, or you being the only one to see some kind of videos as a member of the channel. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Watch out for the next video on multiplying sorts. Bye.